Righto, continuing on with our work with differentiating e to the x. I've got a slightly more complicated problem. So find the gradient of the tangent to this mess at the point 0 and 3 on 2. Where to begin with something like this? Well, much like we did with the negative powers, I believe it was, we can actually divide each term of this by the denominator. So first thing I'm going to do is I'm going to write y equals, now e to the 3x divided by 2e to the x. We minus the powers when it's being divided, so I'm left with half e to the 2x plus, then I have e to the negative 2x divided by 2e to the x, so again minusing the powers, I'm going to have half e to the negative 3x. If you're wondering where the half is coming from, it's because I have one of these divided by two of these, so it's 1 divided by 2 at the front, which gives the half. And then I also have plus 1 over 2e to the x, so I'm going to write that like this, which, you know, if I write that in a slightly nicer way, I could say that's half e to the 2x plus half e to the negative 3x, and then plus half e to the negative x. So, I've got my equation here. Now I need to differentiate this. So dy dx is equal to, now remember that the derivative of whatever the power is goes down the front, so that 2 is going to cancel out with the half and just leave us e to the power of 2x. The negative 3 is going to go down the front, so instead of being plus, that will actually be minus. And then it's 3 on 2 e to the negative 3x. And then the minus 1 goes down the front, so it makes it minus half e to the negative x. We're finding the gradient at the point 0 and 3 on 2. In this case, the 3 on 2 is completely irrelevant. It's there simply to distract you from your answer. We're only interested in this x value of 0. So I'm just going to go when x equals 0, we get dy dx equals e to the power of 0 minus 3 on 2 e to the power of 0 minus half e to the power of 0. And we know that e to the power of 0 is 1, as is anything to the power of 0. So that's just equal to 1 minus 3 on 2 minus 1 on 2, which should be negative 1. So therefore, at the coordinates listed there, the gradient is negative 1. Anyway, we'll leave it there, and I think I've got one more example to go through with this, so I'll play that shortly.